Alright, this is homework help for section 1.6. I'm going to do 3 problems for you today to try to help you out with your homework. I'm going to evaluate a least integer function, or what we call a step function. We're going to graph a step function, and then we're going to go ahead and graph a piecewise function or compound function as well. So I'm going to start by doing the evaluating on the step function. So when you see the symbol, the symbol our book uses looks like a bracket with an extra bar on the inside. That's representing our step function. When you have to evaluate, treat it like any other parenthesis. For letter A here, it's asking us to evaluate f of 1.3, and we should remember that because it's in parentheses that's the x value. So they want us to plug 1.3 in for x here and then to simplify or evaluate. So we're going to go ahead and do that for letter A, and I'm going to plug in the 1.3 so that it looks something like this. And now before I actually apply the rule for that greatest integer or step function, I'm supposed to simplify what's inside that bracket as far as I can. So I want to multiply these two numbers together first to get 3.9. Then I'm going to go ahead and subtract the 1. And so eventually inside that greatest integer function or step function, I eventually end up with 2.9. And then we just have to remember what the rule tells us. The rule tells us to take whatever this number is inside here and always round down. So it's not a traditional rounding like you're used to. You always round it to the integer smaller than that one. So for example, this would round down to 2. So it's 2 times 2, or the y value, or that f of 1.3 would actually give us 4. So if we were going to graph the greatest integer function, we would plot the point 1.34. Letter B, of course, same thing, nothing different. I'm going to take 2.4 this time and plug it in for x. So I am going to end up with 2 times, inside that goofy bracket or greatest integer function, I'm going to have 3 times 2.4 minus 1. Again, I want to simplify that as far as I possibly can. So I'm going to multiply those two together first to get 7.2. Then of course I can subtract 1 to get 6.2. And now that I've got just one number inside there, I can go ahead and apply the greatest integer function rule, which again means to round down. And so it's going to be 2 times, this would round down to 6. Multiply it 2 times 6, and you finally are going to get 12. And so evaluating this particular function at 2.4 is going to eventually give me a y value of 12. So letter C, doing letter C, again, it's nothing different. You're still plugging in this x value in for x. Sometimes a little more tricky when you've got a negative number, because you just have to be a little careful. So we again plug that in, and we know if we multiply those two numbers together that I'm eventually going to get negative 3.3. I again have to simplify all the way down to just one number inside that bracket, so I end up with negative 4.3 as that number. And then just like we did for these, once I get it down to this number, I round down. Now instinct's going to want to tell you to round that down to negative 4, but think about on the number line, negative 4 is actually bigger than negative 4.3. So this one, when I round down, I actually need to round that down to negative 5. So that's what I mean by it can be a little tricky when you're working with negative numbers. So think if you actually drew out the number line, you're going to have 0, eventually you have negative 4 over here, eventually negative 5. We're looking somewhere in between there. If I round down around to the left, I'm actually looking at negative 5. Alright, now I go ahead and evaluate, and it looks like it's negative 10. So there is how you evaluate with a step function. Second one, like I said, that I was going to do for you is going to be graphing a step function. So the step function that we are going to graph is f of x is equal to negative 2 times, inside it's 3x plus 2 minus 1. And the nice thing about a step function or a square root function or a quadratic function or any function that we've been dealing with this year is that they all sort of graph the same way. You always have to find an important point, a lot of times called a vertex point. And similar here, if you look at, just make up a random quadratic equation, if I look at this, and of course it's in vertex form to make it a little easier for us, if I look at this equation, I know the vertex point is 1 if I set what's inside the parentheses equal to 0 and solve, and then the y value is -3, that outside number. And of course that would be, if I was graphing, it would be 1, -3, there's that point, and I would use my other information on that equation to help me figure out that it opens up, it's a little narrow, and so on. Big idea is I want to figure out how to get that vertex point, because whatever I did here, I'm going to do the same thing here. So set what you see inside the bracket or parentheses equal to 0. So 3x plus 2 equals 0. You don't necessarily need to show this when you're doing your work, but you're going to subtract 2 divided by 3. And so I end up with -2/3. That is going to be the x value of my sort of vertex point, or we're going to call it a starting point. And then the y value is this outside number, it's -1. So I'm just going to label it SP as kind of my starting point. It's -2/3, -1. So that's important. A couple other things I want to look at when I'm looking at a step function is I want to know how long is the step, and then what's the gap in between the steps. So I know the starting point is going to be -2/3, and I'll have to approximate that a little bit, -1, so it's right about here, closed circle. And now I know a normal step function is 1 unit long and then an open circle, if you remember what we were doing in class. Well, how do I figure out how long it is, and then do I go up 1 over 1, up 1 over 1? How do I figure all that stuff out? So here's what I do. I want to go ahead and look inside the bracket and look at what's being done to x. It's being multiplied by 3. That number, the number multiplying times x, that number is telling you how long this step is. And remember, it's the opposite of what it looks like. So normally you see a 3, you're thinking, oh, that's going to triple the length of it. It's actually the opposite. Why is it the opposite? Because look what you did over here. When you solved, you had to divide by 3. So again, it just does the opposite of what you think it would do. So instead of stretching it out to be 3 units long, it's actually going to shrink it in to be a 1/3 unit long. So a little messy here. I should have probably given myself a little bit bigger graph. But I'm going to go ahead and draw a 1/3 unit open circle. The number multiplied times the y value, or the original function itself, in other words, it's multiplied times the bracket or the parenthesis or whatever the case may be, that's the distance that you need to move before you put your next point. So it's 1/3 unit open circle. This is saying from that point go down 2 units, closed circle, 1/3 unit to the right, open circle, down 2 units, closed circle, 1/3 unit to the right, open circle, and just continue to follow your pattern. And like I said, I should have made my tick marks maybe a little bit bigger so it wasn't so messy. But this is basically what your step function is going to end up looking like. And then of course follow the pattern, just like slope. If you work backwards, you would go up 2 units, that would be the open circle. You would go 1/3 unit to the left, closed circle, up 2 units, open circle, 1/3 unit to the left, closed circle, and just continue to follow the pattern so that you have what looks like a stair-step pattern. Now the whole reason I do this starting point thing is that I eventually, if I was looking at your test, I would want you to put a little box around that one. That one's your starting point, and that's the one I'm going to look at and say, okay, yeah, you started in the right spot. It's very possible that you make some errors looking at this and end up starting here, and you just get lucky and end up starting in the same spot. Not very likely, but it could happen. So please, when you're doing this on your homework, and it's something I'll remind you to do on the test, put a little box around the starting point. Probably could figure out which one it was if you didn't do that, but it would help me out if you can. All right, on to our third one. The last one that we are going to do today is graphing a piecewise function, which sometimes can be a little tricky for everyone. All right, so I've got my little piecewise function. I've got the little domains. Remember, those are going to be important to help me figure out what's going on. And when we did this in class, we said a lot of times you want to draw this in very lightly when you're doing it. I'm going to basically draw in this entire thing, but I'll draw it in lightly, and then I'll make dark what I need to what I'm actually going to graph. I can see that's just a line with a y-intercept of 3, so go up 3, put a point. I can see the slope is -2, so go down 2, 1 to the right. And again, like I suggested before, draw this in very lightly. There's where that line is. And then regardless of whether this is equal to or not, whatever number this is, I usually will plug this number in, and it gives me what I again call the starting point, or it's going to be an endpoint on my domain. If I plug in -1, I can see I'm eventually going to get a y value of 5. So I move over here to negative 1, 5. And of course, it should be on this line somewhere, depending on how accurate we're. Open circle, make sure you pay attention to that. So negative 1, 5, open circle, that's my starting point. And now look at your domain. It says x is less than negative 1. Less than, the arrow's kind of pointing which way it wants you to go. It wants you to make darker everything on the left. So when I look at this line, this is actually the graph that I want. I really don't want that. So that's why I make it really light. Now I'll make this darker to show that this is actually the part of the graph that I want. And this isn't the only way that you can do this. If you want to, you can just plot that point to start with and then use the slope. It's negative 2. You do want to pay attention that you're going to the left, so you can use the slope, go up 2, 1 to the left, up 2, 1 to the left, and then go that direction. I'm going to jump down to the last one because that's also a line, tends to make it a little easier. Y-intercept of 1, slope of 1/3, so up 1, to the right, 1, 2, 3. Again, for right now, draw this in very lightly. Going to plug in the 6, the x value that they gave me, part of the domain. Again, doesn't matter if it's equal to or not. Plug in the 6, it looks like I get 2 plus 1 or 3. And so I plot 6, 3. Close circle this time because it is actually equal to. And now I can just look at this inequality and see it's greater than, or again the arrow is telling you which way to go. It wants me to pick everything to the right. So from that starting point, this is the stuff that I'm going to actually make darker. This is actually my graph. Again, if you don't like doing it that way, you can always plot that starting point and then use the slope. It's up 1, 3 to the right, and I do want to go to the right because of the inequality, whichever you think is easier. All right, now looking at the one in the middle, it's a parabola. I can see the squared, and I notice it's not in vertex form, which means normally I have to complete the square, but if you remember, x equals negative b over 2a is a shortcut for completing the square, and that's going to be a little quicker than completing the square, so we'll do that. So a, b, and c, it's negative b, so opposite of negative 4, or 4, divided by 2 times 1. Looks like my x value is 2. And quick reminder, how do I get the y value? Well, I take that 2 and I plug it back in. So y is going to equal 2 squared minus 4 times 2 plus 5. 2 squared I know is 4, minus that eventually becomes 8 plus 5. If you remember what I said in class, when you look at the first two numbers, one of those numbers is always going to be twice as large as the other, and you can see this one's twice as large as this one. Just a nice thing to use to check. If that doesn't happen, you know that either you did this calculation wrong or that x value is not right, one of the two. It happened for us, so we're good here. I can subtract to get negative 4 plus 5, or it looks like my y value is 1. So the vertex point for this parabola is 2, 1. I'll go ahead and graph that point. Again, for now I'll graph it light because I'm not sure what I'm going to have for my graph. Now I can also see that this opens up, and I could just give it a general shape if I wanted to. Generally I want to look at the domain and plug in the two numbers they give us. Those are kind of the endpoints. So if I plug 0 in for x here, I'm going to get 0 minus 0 plus 5, or 5. So I'm going to plot the point 0, 5, pay attention to the inequality, equal to, so I'm going to have it closed here. I'm also going to do the same thing with the x value of 5. Again, doesn't matter if it's equal to, I'm just going to have an open circle here. But plug that in, and that's going to give me 5 squared, or 25, minus 4 times 5, or 20, plus 5. Looks like that's eventually going to give me 10. So if I come over here to 5, 1, 2, 3, 4, 5, up to 10, that goes a little higher than I have here, so I'm just going to kind of guesstimate it to be right here. There's going to be my open circle. Here's my vertex point. Anytime you have an inequality where you have two endpoints, it wants everything in between. And so I'm just going to kind of draw my parabola between those 2 points best you can. Again, it's a parabola shape. Try not to have it come to a point because we know that that's supposed to be an absolute value. And there's your piecewise function. Remember, it's a function like any other function. If you draw your vertical line or do the vertical line test, you should not be able to touch this more than once, and you can see that that's true. All right, hope that helps for homework for section 1.6. If not, feel free to come in and ask for help.